Good morning, everybody. It is Thursday. We are off again because of snow. You may rejoice, you may be happy, but we're not done with schoolwork yet. So we have a video today to work you through the classwork for today. Just remember, you have to submit this in order to be marked present for the day. This is just more of a video to help guide you, help you understand, so that you're not just, writing things down and hoping. And hopefully it gives us a little bit of interaction together. I would strongly suggest that you pause, try to answer the questions as we're going along. If you don't have a question, you can reach out to either of us. We'll be fine. But here we go. Here's the first problem for today's classwork. So in problem 19, we're given this triangle over here. And first we want to ask ourselves, what kind of triangle is this? And if we look, we have our three angles marked with arcs, showing that they are congruent. And what we know from this is that this triangle is an equilateral triangle, because if the three angles are congruent, then we know that the sides are also congruent. And once we get that, you want to mark these with your tick marks. Since the sides are congruent, it means that the measures of these sides are equal. And then that means, so if you take a minute, try and figure this out yourself. You can set the measures of these two sides equal. So you can set 2x plus 11 equals 6x minus 9. Subtracting x from the right side and adding 9 to both sides will give you 20 equals 4x. And then we get x equals 5 for our first answer. Okay, moving on to question 20. So we are given angle EHG with a right angle here and two tick marks on the sides here, and we want to find out the value of x, which is giving us g degrees. So what kind of triangle do we have here? We have an isosceles triangle, and we know that because we have these two sides congruent. And what we know about when these two sides are congruent is that the opposite base angles are also congruent. How do we know it's isosceles? We just said there are the two congruent sides. And what does it mean about the measure of the angles? The two base angles must have equal measures. So you could write angle G is congruent to angle E, or that the measure of angle G equals the measure of angle E. And we know that by the isosceles triangle theorem, which says if we have a pair of congruent sides, then the angles opposite those sides, the base angles, are congruent. And there's two ways to solve this problem. Both of them are correct. So I'm going to erase everything here. Method one, we take our 90-degree angle here at H, and since we know that the measure of angle E plus the measure of angle G plus the measure of angle H is going to give us 180 degrees, because the internal sum of the angles of a triangle is 180 degrees, we take 90 plus 3x plus 6 for angle G plus 3x plus 6, since E and G are congruent, equals 180. Do some algebra, we get 90 plus 2 times the quantity of 3x plus 6, or you could alternatively write 90 plus 6x plus 12 equals 180. I combine like terms here. I'm sorry, I subtracted 90 from both sides, and we're left with 2 times 3x plus 6 equals 90. Using the dividing through by 2 gives us 3x plus 6 equals 45. And this is all algebra. There's different ways you could do it. You could have distributed the 2 up here. You could have distributed the 2 down here. I just chose to divide through by 2. But what you get then is you get 3x equals 39. And you'll get x equals 13. And what you want to do is you want to plug this back into your equation. You'll get 13 times 3 is 39, plus 6 is 45. Being the measure of angle G is 45, the measure of angle E is 45. You get 45 plus 45 is 90. Plus 90 gives you 180, so x checks out. Method 2 is we know that h is 90 degrees. By the isosceles triangle theorem, we know that angle E and angle G must be 45 degrees because E must be 45, G must be 45. They have to be complementary. So since we know that angle G has to have a measure of 45 degrees, we can do 3x plus 6 equals 45. Subtract 6 from both sides, you get 3x equals 39. And we still get x equals 13. So that's 2 ways that you could have done this problem. You may have done it a different way. You might have done the algebra a little bit different. As long as you get x equals 13, you're okay on this one. Okay, for problem number 21, we're given triangle WXY with angle W measuring 52 degrees, angle X measuring 6y minus 2 degrees, and angle Y measuring 4x plus 20 degrees. What kind of triangle is this? You notice we have these 2 tick marks here, saying that WY is congruent to WX. Because of that, we know that it is an isosceles triangle. And what does this mean about the measure of the sides of the angles? Well, we know that angle X is congruent to angle Y. And we also know that WX is congruent to WY, which means that the measures of angle X and angle Y are equal. And the measures of angle of side WX and side WY are equal. Now there's 3 methods to solve this problem. All are correct. I can actually keep those tick marks in, that's okay. Just looks a little funky when the screen's transitioning. So what we can do is we can say, okay, well, 52 degrees plus the measure of angle X plus the measure of angle X equals 180 degrees, because the measure of angle X equals the measure of angle Y. We have 52 plus 2 times 6y minus 2 equals 180 degrees. Subtract 52 from both sides gives us 2 times 6y minus 2 equals 128. And again, this is algebra. You can do this like we did the last problem. You can distribute the 2. You can combine like terms up in step 1. It doesn't matter as long as you're following the PME. Please excuse my dear Aunt Sally. Divide through by 2 on both sides. You get 6y minus 2 equals 64. 6y equals 6. And then y equals 11. But remember, we want to also solve for x. So we check. We know since x and y are congruent, 4x plus 20 also equals 64, which is what we got for the measure of our angle x over here in step 4. Then you subtract 20 from both sides. You get 4x equals 44. X equals 11. And we always want to check our work. So we want to make sure that these two angle measures are equal. So we substitute in 11 for y and 11 for x. So we get 6 times 11 minus 2 equals 4 times 11 plus 20. And we get 64 equals 64. So that checks out. We have x equals 11, y equals 11. Method 2 is almost exactly like method 1. Although instead of starting with y, we're going to start, instead of starting with 6y minus 2, we're going to start with 4x plus 20. Doesn't say we're starting with x, but we're starting with angle y. The y is in the x is in the y. A little confusing, but that's okay. That's math. So we get 52 plus 2 times 4x plus 20 equals 180. Subtract 52 from both sides. You'll get 2 times 4x plus 20 equals 128. Divide through by 2. You get 4x plus 20 equals 64. Subtract 20 from both sides. You'll get 4x equals 44. And just like in method 1, we get x equals 11. Now that we have x equals 11, we want to make sure we get the value for y. We see in step 4 that the measure of the angles is going to be 64 degrees. For our check, we know x and y are congruent. Use 6y minus 2 equals 64 degrees. We get y equals 11. If we add 2 to both sides, you get 6y equals 66. Divide through by 6, y equals 11. And since we have x equals 11 and y equals 11, we substitute in. We put in the 11 for x, the 11 for y. 4 times 11 plus 20 equals 6 times 11 minus 2. 64 equals 64. So our values check out again. Method 3 for doing this problem takes a little bit of a different approach. We know the measure of angle x plus the measure of angle y plus 52 equals 180 degrees. Remember that the measure of angle x equals the measure of angle y. What we do is we substitute in angle x wherever we see angle y, and we'll get 2 times the measure of angle x is going to equal 128. We subtracted 52 from both sides. And we know that the measure of angle x equals the measure of angle y equals 64 degrees. We divide through by 2 up here to get that 64. Then we set them to we want to set them to 64 degrees separately. We get 4x plus 20 equals 64. 4x equals 44. X equals 11. And 6y minus 2 equals 64. Add 2, you get 6y equals 66. And you get y equals 11. So our final answer for both of these problems, or for this problem using any of the methods listed, is x equals 11, y equals 11. And you could have done, like we said, you could do the algebra differently anywhere as long as you get the values x and y are equal to 11. And for problem 22, we have triangle MLP with the measure of angle M equals 60 degrees, the measure of angle P equals 60 degrees. So what kind of triangle is this one? Think about this one for a moment. It has to be an equiangular triangle because the sum of the internal angles of a triangle has to be 180 degrees, which means that the measure of angle L plus the measure of angle L plus the measure of angle M plus the measure of angle P has to be 180 degrees. Subtracting 60 and subtracting 60 means that the measure of angle L has to be 60 degrees. Because the triangle is equiangular, so right here, it's the sum of the angles of a triangle is 180 degrees, so angle L must measure 60 degrees. Since all the angles are congruent, all the sides must also be congruent. And because we know that, well, we know that ML is congruent to LP and that's congruent to PM, which means that the measures are equal, or that 2y plus 6 equals 5x minus 3 equals 4. The easiest way to do this is to take 2y plus 6 equals 4. 2y equals negative 2, subtract 6 from both sides, and you get y equals negative 1. So y equals negative 1. And we want to do the same thing for x. We're going to take 5x minus 3 equals 4. Add 3 to both sides, you get 5x equals 7. Dividing through by 5 will give you x equals 7 over 5, or roughly 1.4. And I accidentally clicked, so I'll just write that up here. X equals 7 divided by 5, or 1.4. That should be an equal sign, not a approximately equal sign. Just take a minute, copy that down. If I jumped ahead too fast, you can go, you can rewind it, pause it, put me in slow motion. We'll see you back here for a proof. Okay, for our last problem, we're given a proof. We're given that xy is congruent to xz, that w is the midpoint of xy, q is the midpoint of xz, and we want to prove that wz is congruent to qy. So the first thing you want to do is you want to try to determine how you're going to prove what you want to prove. So we're looking at this segment here and this segment right here. We want to prove that these two segments are congruent. We're not given any direct information, but we know that we have a midpoint and a midpoint over here. So we're going to do something with this information. And then we want to connect those down there to work with triangles. And we want to start with this here. Trace that over there. And that's these two triangles here, triangle WZY and triangle QYZ. Now we have a number of tools to prove triangle congruence. We have SSS, SAS, ASA, AAS, hypotenuse leg. We now have the isosceles triangle theorem. We have the converse of the isosceles triangle theorem. We know about equilateral triangles. So we could use any of those, but we have to prove triangle congruence in some way because we're working with triangles. It's the tools that we have right now. And because we're looking to prove segments congruent, we're likely going to be trying to prove that the corresponding parts of congruent triangles are congruent, or CPCTC. Before we could use CPCTC, we need to prove that these triangles are congruent in some way, shape, or form. So what we're going to do is we're going to start with our first bit of given information. We have XY is congruent to XZ. And that's given. Once we have that, because we want to try to work with measures, we want to make sure that we justify that these segments aren't just congruent, that their measures are also equal. So when segments are congruent, the measures are equal. So we write XY equals XZ. And that's the definition of congruent segments. Once we have that bit of information, we want to start working with our next bit because we can't really do a lot with that yet. That doesn't give us any part of the triangles that we want to have here. That's given information. Now, we know that this is the midpoint. And we could say that XW and WY are congruent and that XQ and QZ are congruent, but that's really not going to help us because we're not worried too much about this triangle part up here. We're worried about this down here. So what we're going to do is we're going to say that xw equals wy and that xq equals qz by the definition of midpoint. And if you remember in class, we'd say that you use the definition of midpoint when you want to write an equation. And if you look here in step 2, we also have measures because we're going to try and use that in an equation of some sort. Because we're writing an equation, we have xw plus wy equals xy, and xq plus qz equals xz. And that's the segment addition postulate. Now we're working with the first side of each of these triangles. Well, what we can do is we can set xw plus wy equal to xq plus qz by substitution, since xy equals xz. So you see we have the xy. I'll draw it in green. So we have our xy here, our xz here. Since xy equals xz up here, it means we can set these two equations equal to one another. So xy plus wy equals xq plus qz. And the reason for that being substitution. Now we have an equation. And now we're going to do a little bit of manipulation. Since we wrote that xw equals wy and xq equals qz, we're going to substitute in wy wherever we see xw. I'll do that in purple. So here's this statement, and here's this statement. So we had an xw here. So we put that there. And we had an xq here, so we substituted qz in there. We've done some substitution from 4 into 6. Now we're starting to work with the sides of these triangles here, the legs, if you will. Similar to how we did this in the previous problems, we get 2 times the length of wy equals 2 times the length of qz. That's algebra there. We're simplifying, we're combining like terms. And our next step is going to be dividing through by 2. And that gives us wy equals qz. And you can write that the division property, line 8 divided by 2. And we want to take it back to our original format and say wy is congruent to qz. Once we have that bit of information, we want to mark that on our diagram. And I'm going to do it in yellow. I don't know if it's going to be very hard to see or not. I'm going to mark it with an extra thick tick mark. So wy is congruent to qz. We have a side. We also know that angle xyz, I'll start erasing some of this over here. I'll mark this up in red. So angle xyz and angle xzy are congruent. How do we know that these two are congruent? Well, we are given that xy is congruent to xz, which means that the legs of these two triangles here, xy and xz, are congruent, and then we can use the isosceles triangle theorem to say that the base angles are congruent. And once we do that, we now have angle y and angle z are congruent in these triangles. Now we have a side, we have an angle. If you look at, well, I erased it now, but in our drawing, we had highlighted YZ in red and blue when we were showing the triangles, we know that YZ is congruent to YZ by the reflexive property. Mark that with a blue tick mark. What we have here is WY congruent to QZ, angle Y congruent to angle Z, angle YZ congruent to angle, or segment YZ congruent to segment YZ. We have a side angle side, which means that the triangle WYZ is congruent to triangle QZY by SAS in steps 10, 11, 12. I should write these because good habits are hard to form and hard to break. But we're not quite done because we wanted to prove that WZ is congruent to YZ, or WZ congruent to QY. But because the triangles are congruent, we know that corresponding parts of congruent triangles are congruent. So WZ is congruent to QY by CP/CTC. And that's it for problem 24. So take a minute, look through it. See, if you need to rewind, watch how we pull the pieces together that we were given. And we have one more problem. Okay, this is the final problem. This is a challenge problem. I believe this is actually honors only. If you want to try this and you're in the normal classes, feel free to copy it down, pause the video, draw the diagram. We're going to be working through this one just like the other ones. A little bit of practice is never a bad thing for anybody. What we're given with this last problem is, in the figure at the right, if triangle WJZ is equilateral and angle ZWP is congruent to angle WJM is congruent to angle JZL, we want to prove that WP is congruent to ZL, which is congruent to JM. Now, I'm going to be making a lot of marks on this. I'm going to be erasing a lot, so I would suggest you can draw your own because I only have so many markers here. So we're given off that WJZ is an equilateral triangle. That ZWP, this angle here, WJM, this angle here, and JZL are all congruent. And we're trying to prove, I'm going to mark it in light blue here. I should actually mark that in red. So that's in red. And we're going to prove that these are congruent. So we're looking to prove that this is congruent. So I went a little too far. We're trying to show WP, not WL. ZL and JM are congruent. And if we're looking to show that segments are congruent, we're going to try to be showing that triangles are congruent as of right now, because we're working with triangles and we have triangles within triangles and triangles within triangles within triangles. It's triangleception right here. But once we show that we have triangle congruence, we could potentially try to use CP/CTC. We're going to be trying to show the triangle congruence by side, angle, side, 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 angle, angle, side. Any of those would potentially work. We don't know which one we're going to work with. However, we are given an angle to start, so we're likely not going to be going for side, side, side. And it doesn't look like there's any right angle, so we can probably eliminate hypotenuse like too. So let's begin working through this. So we know that WJZ is equilateral. Because WJZ is equilateral, we also know that it's equiangular. And I'm going to highlight that in green. So I'm going to put a green dot here to show that. It means that this angle is congruent to this angle, and that's congruent to this angle. And that's always true. If a triangle is equilateral, then it's also equiangular. So we know that ZWJ is congruent to WJZ, and that's congruent to JZW. So JZW, that's these whole green angles I just marked here, by the definition of an equiangular triangle. Now, once we have this, what you can see is we have these two smaller angles that are formed by this segment here. The sum of these two angles is going to equal the larger angle here. So we want to keep that in mind for moving into the future. So we have now that we have the angles are congruent, we know that the measures are equal. And that's the definition of congruent angles. We also know that ZWP, WJM, and JZL are all congruent. That's our given information. Now we have something to work with these angles, and we have something to work with these smaller angles. Since these angles are all congruent, we also know that the measures are equal by the definition of congruent angles. So remember how we said before that we're going to be using these smaller angles. If we look at this, we know that the measure of WJM plus the measure of ZJM is going to equal WJZ. It's going to equal this whole angle here. So this little red one plus this unmarked arc, those two together, the measures equal the larger green arc here. And we're going to formally state that in step 7. So the measure of ZWJ equals the measure of ZWP plus the measure of PWJ. WJZ equals WJM plus MJZ. And the measure of JZW equals the measure of JZL plus the measure of LZW. And we know that by the angle addition postulate. I'll give you a minute to catch up, copy it down. And you should be working through these before we go over. It doesn't do you any good to just sit here and write it down. You want to try and understand it. You want to try and practice it. You learn math best by doing it. Or at least attempting, giving it your best shot. And if you have an aha moment in this, pause the video, try to work through it and see how it works out. We know that these three angles are all congruent and that the measures are equal by step 6. So we can actually set these equations, ZWP plus PWJ and WJM, MJZ, JZL, and LZW equal to one another, because if they equal this and these three are equal, then these equations are all equal to one another. And we do that by substitution. We stated it in statement 4 that the measures are equal. And now we're just manipulating the equations. We're doing a little bit of algebra here, some substitution. Now, if you look at this, and this is really cool, we have that these are equal here in statement 6. We have ZWP here, WJM, JZL in all these equations. So what we're going to do is we're going to substitute a little bit. Wherever we see the WJM, we're going to put in ZWP. I should probably highlight that, and I'll put that in blue. So we have the measure of ZWP here equals WJM and JZL. Well, here's our WJM, and here's our JZL. And we already have a ZWP here. So what we're going to do is we're going to put in ZWP, ZWP, and ZWP in this. Once we have that, we can start manipulating this even further. So this is another substitution from 6 into 8. And once we have this, what we're going to be able to do is we're going to be able to subtract the measure of ZWP from every expression. So we subtract ZWP, 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 and that gives us that these last three measures are equal to one another. So I'm going to mark these angles in purple here. So PWJ this. So we have PWJ, MJZ, and LZW. These are all the arcs highlighted in purple. I should do twos just so formality purposes. And I'm actually going to erase the green ones because we've used that bit of information for ourselves already and clean this up a little bit. And that's by subtraction. We subtracted ZWP from each side of these triangles, or from the expressions. Since the measures are equal, we know that the angles are congruent. And that's the definition of congruent angles. So since we're looking to prove that WP is congruent, I'm going to try and highlight this again in green. So it looks like what we're looking to work with here are these triangles here. WP, and we have this angle already. ZL. So we're going to be looking to work with this triangle here. And JM. We know that JW is congruent to ZJ, is congruent to WZ, because we are given that this is an equilateral triangle. So these outside measures must all be congruent. And now if you look here, we have our angle, we have our side, and we can do ASA. We have ASA in stages 5, and I should have written these down. I'm sorry, I didn't. We have A, SA, and so it's ZWP. Okay, right, these were the tick marks I erased, I'm sorry. Or the arcs that I erased, I'm sorry. So we have angle, side, angle. And now that we have angle, side, angle, I erased the red arcs earlier. I'm sorry, that was my mistake. If you look, we have this arc, and I should mark these outer edge in blue. There we go. It's a little bit sloppy, but we have the red angle, the blue tick mark, and then the purple angle, the red angle, the blue tick mark, the purple angle, the red angle, the blue tick mark, and the purple angle. So these three triangles are all congruent by ASA. And then because they're congruent by ASA, we know that WP is congruent to ZL and that's congruent to JM by CPCTC. If you watch this to the end, I hope you enjoy the rest of your snow day. Maybe we'll see each other tomorrow. Maybe we won't. Let's see what Mother Nature has in store. Go play, make some snow angel shovel. We want to hear about what you did when we come back, whether it be this week or next week. Have a wonderful day, and see you all soon.